Hi everyone, hope you're all good and managing well. So I started this new playlist, Yeah, but why? As I wanted to explore the reasons and logic behind why we are taught certain rules in maths this specific way. I'm starting with a topic in A-levels that tends to frustrate people in the beginning, at the first year. It's called differentiation from first principles. You've probably heard of it. This is why.
We have a curve defined by y equals f of x, and we want to find the gradient at this red point. Its x-coordinate is x, and the y-coordinate can be mentioned as f of x. Using our GCSE knowledge, to find the gradient we would need a second point. So we have this one, and it is h to the right of the first point. Therefore, it has an x-coordinate x plus h with a y-coordinate f of x plus h. Now, if we were to find the gradient between those 2 points, we could see that gradient would not be as accurate as the gradient at that first point only. We can see a gap between that gradient and the curve. We know that the gradient between any 2 points is dy over dx, which in our case would be f of x plus h take away f of x over the difference in x, which is x plus h take away x. And then we can see that the denominator cancels out and simplifies to just h. Now looking at the gradient is not as accurate as what the gradient would be at that first point only. So to make it more accurate, let's move the second point closer to the first point. Now when we move it closer, we see that the gradient between the 2 points is closer to what the gradient would be at the first point, but there is still some inaccuracy. So what we want to do is move the second point so close to the first point that the distance h between them is infinitesimally small. It's so small that the difference between them is basically negligible. It's almost zero. So we want the value h to approach zero. It's not equal to zero, but it's so small it might as well be zero. And that's why we write in front of our expression lim, which stands for the limit, as h tends towards zero. And this is our equation for differentiating from first principles. Let's do it again sometime. George out.